Right, we're going to look at some parametric equations today. This should be a review from your pre-calculus days. Remember, these are different than functions. Okay, one of the big differences, as you notice, they can actually, they don't pass the vertical line test. So a lot of times we do this by using a third variable, so not just x, y's. A lot of times we use t or theta. So we have x equals f of t and y equals g of t. They're two different functions that will actually define x and y. If you had physics, you probably use this a little bit to describe some motion. All right, these are what we call our parametric equations, where t is our parameter. All right, here's an example. X equals the square root of t, y equals t. We have some restrictions on t being greater than 0. And we're going to look at just how to graph this quick on the TI-89. Okay, we'll go to our mode. And we want to go to graph. We want to make sure we're parametric. Put in our x of t1, square root of t. Follow our button stroke. Set up your window to the appropriate window. Hit graph. And we will come up with this graph of our 1/2 of a parabola, it looks like. Now it looks a little distorted, so you can go to zoom square. There, it looks a little bit nicer. And now we can confirm this algebraically, which we're going to do a little bit more of. So we have x equals the square root of t, y equals t. We can really just do some direct substitution here. So we get y equals the square root of x equals the square root of y. Square both sides to get x squared equals y. Don't forget about our restrictions. So we just had the equation y equals x squared, but we have the restrictions x is greater than or equal to 0. So we have a parabolic function. If you look at a circle, basically the same thing. You let x equal a cosine of t, y equals sine of t. 0 is less than or equal to t. Restrictions again. And this is just a quick review from trigonometry. We basically have the unit circle here. And then we get our parametric equation. Again, try this on your calculator. To graph these two, we'll use this for our window. And put this in. We use our t max, basically 2 pi, that's our restrictions. And we get our little circle. Excuse me, let me go back to that. Right. Here's an ellipse. Again, solve for your cosine. And we always go back basically to that sine squared equals cosine squared. It's going to be their easiest one to use. Some direct substitution. And there's our equation for an ellipse. All right, just a couple that you might want to know. General equations, center at 0, 0. Circle has a radius r. Here's a rectangular, parametric, ellipse. And what I want you to do for your homework is see if you can, given x1, y1, x2, y2, and the parametric equation for a line x equals x sub 1 plus a sub t, y equals y sub 1, b sub t. Find a parametric equation for a line segment with endpoints -2, 1, and 3, 5. I want you to try this on your own. Enter your equation with the correct restrictions into the Google form that's located on the site.